Hey guys, good morning, or I guess it's afternoon today, and welcome to Solutions, the new unit on solutions that we're starting today. So welcome, this is Unit 10. I bet you're wondering, Mr. Smith, what happened to Unit 8? Um, well, it's still going to come up, but hopefully by the time Unit 8 rolls around, that's going to be our last unit, and we'll be back in school so we can actually teach you how to do it. Unit 8 is pretty complex. So Unit 10, solutions, a little bit easier because we've kind of talked about it a little bit already. So that's the nice thing about Unit 10 solutions is that we're going to start off here. If you look at the in up on the board, you'll see that it asks, what are the two types of mixtures we've talked about earlier this year? So, starting off today with a little bit of a review of Unit 2. So, what I want you guys to do right now is go ahead and think, what are those two types of mixtures we've talked about earlier this year? Here's a little hint about that, is that they both begin with H's. Both of these types of mixtures begin with the letter H. So, think about that. Did you get homogeneous and heterogeneous as your two type of mixtures? That was the hope. That was what we were looking for. So if you remember, that's a little review of Unit 2. And then the next thing we want you to do is I want you to think of what are three everyday mixtures. So maybe write these three everyday mixtures. Go ahead and write that down on your left-hand side of your notebook. Okay, pause the video if you need more time. Here are three everyday mixtures that I came up with. Number one, we've got milk and cereal. Number two, we've got air. Air is a mixture. And then number three, we have honey. So milk and cereal, probably the easiest, most straightforward. Milk is a solution, and cereal is also a mixture. So combine them together, and you get a heterogeneous mixture. Remember, heterogeneous, we said, was something that's chunky, whereas something like air, that's going to be homogeneous, because remember, air is smooth. Chunky, heterogeneous, homogeneous means smooth. Lastly, honey. Honey's got it's some water and it's some sugar, so that's going to be homogeneous as well, because once again, honey is smooth. Now, as we move forward into this unit, we're going to talk about the differences between heterogeneous and homogeneous. And actually, it's no longer going to be, there's a category for heterogeneous, there's a category for homogeneous. It's going to be a little bit more of a scale. Some things are very heterogeneous, some things are kind of heterogeneous, some things are very homogeneous, some things are kind of homogeneous. So there's kind of a scale, and we'll talk about what comes in the middle. Those are actually called colloids. Now, how we determine how far it is on the heterogeneous side or the homogeneous side is based on one thing. And that one thing is particle size. So you're going to want to write that down, particle size. And the idea here is if the particle's small, it will dissolve. So for example, the particles in air, like oxygen, nitrogen, they're all at an atomic level. So they're very, very small. So they're going to dissolve right in with the rest of the air. Whereas something like cereal, individual flakes of cereal are way too big. They're not going to all dissolve in milk. So that particle size, kind of the idea here is if the particle's too big, it won't dissolve. So we're going to kind of re-go over what heterogeneous and homogeneous are with some new terms. Sound good? Great. Let's first talk about, if you can see on this left side, we've got mixtures heterogeneous. And it says right away, particles are big enough to be seen under the microscope. So here with heterogeneous, we're dealing with big particles. Write that down, big particles. Now, it turns out there's actually two types of heterogeneous mixtures. Number one is called a suspension. So write that down. And then the other one is called a colloid. Suspension and colloid are two types of heterogeneous mixtures. Now, a suspension is going to appear uniform but settle. So how I like to think of this is I like to think of like salad dressing, for example. You have like a vinaigrette. In order to get it to come out nice and well mixed onto your salad, you've got to shake that salad dressing up first. And then when you pour it out, it's nice and all mixed up. You've got like the herbs and the garlic and the oil and the spices, all that stuff on your lettuce. But then if you sit it out on the counter and let it sit for a little bit, all those herbs and spices kind of fall to the bottom, and then you even see like different layers of liquids. Maybe you've got like a vinegar layer and an oil layer or something. That's a suspension. Here, and then a colloid is our other type of heterogeneous mixture. And a colloid they're kind of tricky to define, but it's a mixture between a suspension and a solution. So some examples of suspension: ketchup, orange juice, paint, and salad dressing. These are all things that you generally need to mix or shake kind of before you use. If you leave paint out too long, paint does separate as well, so you got to stir it kind of before you use it. With a colloid, I know I didn't really give a great definition of it. Colloids have medium-sized particles. So that's something you're going to want to know about a colloid. So they're kind of not, they're technically heterogeneous, but they're also kind of homogeneous, right? They're kind of in the middle because their particles are medium-sized. Some examples of colloids: milk, fog, smog, shaving cream, mayo, and whipped cream. All of these things are things that they kind of have like particles that are kind of just suspended. So, or sorry, that's a bad term to use because we got that other term, suspension. Particles in a colloid here, they're gonna they won't fall down. So if you shake them or you leave them unshaken, they'll still kind of all stay where they are, but these particles are a little bit bigger. For example, milk is water, and then in the middle of all the water, you've got little fat globules. They're small enough that you won't taste them, but if the milk kind of goes bad, those fat globules will start to kind of combine together, and then you'll get chunky milk. So not really ideal. Fog is very similar. Fog has water kind of dispersed in air, and you've got actually tiny little water droplets in your air. So it's kind of hard to see through the fog because of all those water droplets, but you can't necessarily like look at fog and see those water droplets because they're still pretty small. And obviously the water droplets don't fall out of the sky unless it gets too humid, and then you start seeing some rain. So fog's kind of like halfway in between clear sky and like rain. So that's kind of a good example of what a colloid is. Halfway between a suspension and then we're going to call a solution, a homogeneous mixture. So here is this picture that I'm looking for, where we have true solution, colloidal solution, and suspensions. And what you'll notice about these pictures is that you'll see the white dots get bigger as you move from left to right over here. In a true solution, the particles are very, very small, and that makes them easy to dissolve. Colloids, like we were just talking about, particles are a little bit bigger. And suspension, the particles are actually pretty big, and they will fall out of solution after you mix them. So you mix them and they're kind of all like a snow globe type deal, but then they start to fall back down. And in order to get them back into the solution, back evenly mixed, you got to shake them up, but they'll always fall back out. So particle size is what we're talking about here. Solutions are small, colloids are medium, suspensions are big. I would write that down somewhere in your notes. The other thing I want you to know about colloids is something called the Tyndall effect. So write this down. Tyndall effect means the scattering of light by colloidal particles. And the best way to see this, a great example, is when you have headlights in the fog. So Tyndall effect is when you shine a light on a colloid, it'll actually scatter the light, and the light will go everywhere. And so this means that colloids tend to not be see-through. They tend not to be transparent. They're somewhere between either translucent, where you can see some light through them, or they're opaque. You can't see any light through them whatsoever. So Tyndall effect, know that that's a property of colloids. Fun fact, when it's foggy outside, you don't want to put your brights on. If you put your brights on, you won't be able to see anything because it'll just kind of illuminate those water particles in the fog. It'll just make it too bright. You'll only see the water particles and you won't be able to see the road. Instead, what you want to put on is you want to put on your fog lights. And your fog lights kind of don't look directly at the sky. They kind of look lower on the ground. So when you do that, you're just really illuminating the ground, not the water particles in the fog, not the fog. So it's because of the Tyndall effect that you don't put your brights on when it's foggy outside. Fun fact. Let's move on now to homogeneous mixtures. And homogeneous mixtures, their particles cannot be seen under a microscope. They're just too small. So you definitely want to write that down about homogeneous. Particles cannot be seen under a microscope. The only type of homogeneous mixture we're going to talk about is something called a solution. And a solution is a mixture spread through one phase. So this is something that the particles in the solution will dissolve. So they cannot be separated. We're looking at things like Kool-Aid, right? If you run Kool-Aid through a strainer, you're not going to separate it out into Kool-Aid powder and water. You run Kool-Aid through a strainer, you'll just have a wet strainer, and you'll have Kool-Aid at the start, Kool-Aid at the end. Same thing with air. You can't filter the oxygen out of air. If you run air through a filter, you'll catch things like dust, debris, and stuff that isn't actually technically dissolved in air. And you'll still have the same kind of like chemicals dissolved in the air. Also, bronze, you can't run bronze through a filter, so on and so forth. Okay, solution has two parts to it. It's got the solute and it's got the solvent. Now, these two terms are very, very similar to each other. Let's talk about them. Solute is the powder. So if you're dissolving something in water, the solute is the thing you're dissolving. So if you look on the slide, it uses the example of Kool-Aid. So in order to form Kool-Aid, you need water and you need Kool-Aid powder. Those are the two things you need. Kool-Aid powder would be the solute. Water is the solvent. And so in order to create a Kool-Aid solution, you'll see this equation down at the bottom that I want you to write down. Solution is solute plus solvent. So those are the two things you need in order to form a solution, a solute and a solvent. So have those definitions down: solution, solute, and solvent. Next slide. Okay, so I wanted to help you guys kind of remember the difference between solute and solvent. So here are some bad jokes. What do you call a liquid that dissolves stuff? You call it a dissolvent. Because like it dissolves stuff. I don't know. Anyways, and then what do you call an adorable grain of salt? You call that a salt cute. Again, I don't know. They're not great puns, but I don't know. Salt cute kind of sounds like, solute. And then here's a nice picture of a happy little salt shaker. I think it's kind of cute, like a salt cute. So that's what we got going on there. Homogeneous mixtures, again, here you see two pictures of glasses of water, right? So in the first picture here, you got the salt dissolving. In the second picture, this is after it's dissolved. It looks like it's pure water, right? You wouldn't be able to necessarily tell that something's been dissolved. They look clear, unlike colloids, which kind of look translucent, not transparent and not opaque. Okay, next thing we want to talk about is polarity, like dissolves like. So we got two terms that we want you to know: miscible and immiscible. Miscible means that liquids can dissolve in each other. So when I hear the phrase miscible, I think mixable, right? You can mix two things together. Liquids that you can mix together include things like water and vinegar. If you mix water and vinegar together, they will mix, they will dissolve. Immiscible is a term for liquids that cannot dissolve into each other. Immiscible means not mixable. So when we're talking about miscible and immiscible, one thing I want you to notice here is that we're always talking about liquids. This does not apply with a liquid and a solid, and it does not apply with gases. Miscible and immiscible only talk about liquids. So just be aware of that. Two liquids that are immiscible, you might already know this: oil and water. Oil, if you mix oil and water together, you can get them to mix, but then they'll always separate out. Oil will always float to the top, water will always be stuck at the bottom. And so here on this next slide, we see miscible versus immiscible liquids. It's kind of hard to tell, but on the first one, you can see the little test tube on the left that there's a little line between the two of them. And then if you look at that kind of zoomed in portrait, you'll see at the top the red and the blue molecules. Those are my water molecules. They're all floating above it. And then on the bottom, you'll see, I don't know what these bottom molecules are, but they are all together. And there's no mixing between the two of them because they won't. In the other picture over here, you'll see that water molecules and this other like black, blue, and red molecule here, they're all kind of interdispersed amongst each other. So we would say that on the right here, these two chemicals have mixed. They are miscible. And on the left over here, we'd say that these two chemicals are immiscible. They will not mix with each other. All right, that's the end of today's lesson. I know it was a little bit of a long one. Your homework for today is there's a couple problems on a little quiz. Just go ahead and try your best to answer those questions. And yeah, let me know if you have any questions on any of this. Definitions, pretty straightforward that you're going to want to know. Just kind of running through everything again. You're going to want to know the difference between homogeneous and heterogeneous. You're going to want to know suspension, colloid, and solution. You're going to want to know Tyndall effect. You're going to want to know that a solution is made up of a solute and a solvent and kind of what each one of those is. And you're going to want to know miscible and immiscible. So today was a very vocab heavy day. I hope that didn't dampen your spirits, and I hope you're having a great time with the notes and a great time with this class. Thank you guys so much for tuning in today. Have a great rest of your day, and we'll see you tomorrow.